The following question reads that manganese 4 oxide MnO2 catalyzes, it's acting as a catalyst for the decomposition of hydrogen peroxide H2O2 as shown over here. H2O2 getting converted into water and O2, and MnO2 is acting as your catalyst. And the mechanism involves the formation of the intermediate species Mn2 plus. So this information is given that MnO2 is getting converted into Mn2 plus in the first step. That is step 1. And he says in the first step, which is subsequently used up in the second step, state and use relevant electrode equations, construct two equations to show how MnO2 can catalyze this reaction. Now, one thing is provided, and that is that in step 1, uh, MnO2 and Mn2 plus, there is a reaction that's going on. So there is something happening between MnO2 and Mn2 plus. So I need to figure out what the electrode reaction is, and the reactant that I have is H2O2. So let's open our data booklet first and try and figure out this reaction. Now, if you open the data booklet which I have in front of me, you'll notice this reaction, which is MnO2 in plus 4H plus 1 plus 2 electrons, and that's in equilibrium with Mn2 plus plus 2 H2O. And the value that's given for that, the E naught, the electrode potential for that, is given as 1.23 volts. So that is provided. So I've written down. I mean, let me rub this off. This is this is one of the intermediate species that is getting formed, and he's saying that MnO2 gets converted into Mn2 plus as an intermediate, and then it gets converted back to MnO2 because it's a catalyst. Catalysts are always regenerated. Now we are going to focus on this. Always go in the backward direction. Always. reacting with H2O2 and Mn2 plus is getting formed. And then what happens? What happens is I want the Mn2 plus to be converted back into MnO2. So now what I'm going to do is that I'm going to connect this equation with this equation, because if I do that, if I connect the two together, let me put it, these two equations. I'm talking about these two equations. I want the Mn2 plus to be converted back into MnO2. So if I do that, this is the higher potential, so it's going to gain electrons, and this is the lower potential, so it's going to go in the backward direction. And let's write down the equations. The electrons are already balanced, so let me write down the reactants. The reactants are H2O2 plus 2H plus 1. These are my reactants. And over here, the reactant is Mn2 plus 2H2O. And my products are, in the first one, the product is 2H2O. And in the second one, the product is MnO2 plus 4H plus 1. So it is MnO2 plus 4H plus 1. So that gives me this second equation, gives me the second reaction. And this was what we were basically looking for. We wanted MnO2 to react with H2O2 to form Mn2 plus. They had specifically stated that Mn2 plus was getting formed. And then, since it was acting as a catalyst, we wanted Mn2 plus to get converted back into MnO2. And when I reacted MnO2 with the first equation, I figured out that Mn2 plus was getting converted into MnO2. And the reaction was going in the backward direction as well. So, one thing, always remember that species, and it's a conceptual thing, species can act as catalysts under certain conditions. And the conditions are that the species and its electrode reaction should be right in the middle. This middle one over here, its potential should be between the two potentials, the reactions that are taking place, so that it should be able to go forward with one reaction and it should be able to go backward with the other reaction. It has a lower potential compared to the first one, but it has a higher potential compared to the second one, which is why the reaction could go in forward as well as backward reaction in the same mixture. And these would be your final two equations that you're going to get.